This is lesson 3.5b, graphing linear equations in slope-intercept form. The essential question here is how can you describe the graph of the equation y equals mx plus b? So we already talked about slope in the slope-intercept form, where y equals mx plus b, where m is the slope, b is the y-intercept. So how are we going to use this information in order to graph? So let's look at this example 4 here, using slope-intercept form to graph. Graphing 2x plus y equals 2. You need to identify the x-intercept. Well, I can find the x and y intercepts, or I could put it in slope-intercept form. If I put it in slope-intercept form, I'm going to have y equals negative 2x plus 2, because I subtracted 2 for x from both sides to get the y by itself. Just subtract the 2x. So this is telling me that my slope is negative 2 and my y-intercept is 2. So I'm going to come over here on the y-axis and put my y-intercept at 2. Now it tells me I have a slope of negative 2. What negative 2 means is, remember, that slope is rise over run. I have negative 2. Remember, when I have a whole number, the denominator is just 1. So I've got a rise of negative 2 and a run of 1. So I'm going to go down 2 and then over 1. And I'm going to put my point right there. Down 2 over 1. Oops. Right there. So that's going to be our line here. So you're just going to connect through those points, and that's the graph of your line. That's how you graph using the slope-intercept form. Now let's look here at example 5. Example 5 is asking us graphing from a verbal description. So a linear function g models a relationship in which the dependent variable, remember what the dependent variable is, increases 3 units for every 1 unit the independent variable increases. Graph g when g of 0 equals 3. Identify the slope, y-intercept, and x-intercept of the graph. Okay, what we're going to do first is find the slope. It says when the dependent variable increases by 3, that means the change in y is 3. So that's going to be your rise. Remember, it means the change in y over the change in x. So we've got 3, and then it says the independent variable, which is x, changes by 1. So that's over 1, or just 3. Okay? Now it says to find the y-intercept. The statement g of 0 equals 3 indicates that when x equals 0, y equals 3. So the point 0, 3 is going to be that intercept. So the y-intercept is 3. So we're going to plot that point. We go over 0 and up 3. Now we can use the slope to find another point on the line. So a slope of 3, means a rise of 3, run of 1. So rise of 3, run of 1, and I'm off the grid. How am I going to do that? Well, this could also be written as negative 3 over negative 1, couldn't it? Because that would still give you 3. So we're going to do negative 3 and then negative 1. So we're going to put the point right there. Negative 3, negative 1. And then we will graph that equation. And then it also asks us to identify the x-intercept, because this one's the y-intercept. So the x-intercept It's going to be where it crosses the x-axis, which is at -1, 0. So how are we going to use this as far as math goes? When we're modeling with mathematics, we've got a submersible that is exploring the ocean floor, begins to ascend to the surface. Ascend means to rise. So the elevation h in feet of the submersible is modeled by the function h of t equals 650t minus 13,000, where t is the time in minutes since the submersible began to ascend. It asks us to graph the function and identify its domain and range, and then interpret the slope and the intercepts of the graph. Well, first off, you need to understand the problem. You know the function that models the elevation. You are asked to graph the function and identify its domain and range. Then you are asked to interpret the slope and intercepts of the graph. All right, so let's make a plan then. We're going to use the slope-intercept form of a linear equation to graph that function. Only graph values that make sense in the context of the problem, so examine the graph to interpret the slope and the intercepts. So let's do that then. The time t must be greater than or equal to 0. So we can start at 0 here. The elevation h is below sea level. It must be less than or equal to 0. So we're going to go down, and I'm just going to make each one worth 2,000 going down. So this is negative 8,000. This one's negative 12,000. 14 and negative 16,000 right there. We're going to have our time lapse. I'll just say each box is 2 minutes, so there's 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so now the elevation, let's find out what we can do. The domain then, because it asks us to find that domain and range, so the domain is going to be 0 is going to be the smallest number. Remember, it's the x value, so it's going to be this time here. And 20 is going to be the maximum number. We know the maximum number is going to be 20 because we want to know where it crosses the x-axis. So we put h of t. So I'll just put y. We want to know when the y equals 650 times 0 minus 1300 to find the y-intercept. So this would be nothing, so y is going to be negative 1300. So at negative 1300, which is going to be between 12 and 14, so about right there's 1300. That's where you're going to have for the y-intercept. For the x-intercept, if I put in 0 equals 650 times x minus 1300 and solve for x. Say I'm going to add 1300 to both sides, so I'm going to get 1300 equals 650x. Then divide by 650, you get x equal to 20. So it crosses the x-axis at 20. So I would put my point right there. So my line is going to connect those 2 points. So then by looking at this, like I said, my domain is 0 to 20, because after that, it's going to be above the water, and, well, you can't really go too much more above the water without wings. And then it had a depth, so the time is going to go from 0 to 20. But the depth here is going to go from negative 1300 up to 0. So for the range, we're going to put that the range is going to be negative 1300, because that's the bottom number. Sorry, this is kind of writing everywhere. It's not very much room. Well, here, I'll just put it on another screen. So you're going to have the domain is going to be, like we said, from 0 to 20. And the range is going to be negative 1300 less than or equal to h, which is less than or equal to 0. So here, if you figure that out, the slope is going to end up being 650, because that was the m of our equation. So the submersible needs to ascend at a rate of 650 feet per minute. The h-intercept's negative 1300, so the elevation of the submersible after 0 minutes, or when its ascent begins, is negative 1300 feet. The t-intercept, which is the x-intercept, is 20, so the submersible takes 20 minutes to reach an elevation of 0 feet or sea level. Yeah, right over there. Go ahead and show me your notes and get on your clever.